Welcome back to section 6.2, working with rational exponents that are fractions this time. So if you go to, I think it's the second page, very bottom second page, we talk about the property of radicals, the product property and the quotient property. And we had this before when we weren't dealing with the fractions, but if you have two different bases under a particular root, they have the A and B, you can split those into their own separate radicals. It allows you to do work within that single radical and one or the other separately. Likewise, when you're dividing, you start with one radical with a fraction inside, split the radical so you have two radicals, one numerator, one the denominator, and now you can work on those separately or do things to them to make them work for you. Now that part's the difficult part, get them to work for you, and I'll show you that in some examples. This part's not quite so easy, but if you do a few examples, you'll catch on to what we're trying to do. So example 3, using properties of radicals, use the properties of radicals to simplify. So you're looking at this, and you're probably thinking, well, there's no cube roots in 12 that are factors of 12. I can't think of any. Nor are there any for 18. So I'm going to put, just by chance, I'm going to multiply 12 times 18, and I get, this is a cube root, 216. And if you still have that cheat sheet you had back when we were doing factoring, of course it's probably at school in your locker, you might recall that the cube root of 216 was going to be equal to 6. 6 cubed is 216. Again, these are not simple to do, but practice does make it a little easier. Letter B here, they're already split. They're both a base fourth rad, but I want to combine them. So I'm going to make one radical to the fourth root, 80 divided by 5. And I just think about that a little bit. I think that's going to be 16. So the fourth root of 80 divided by 5 is 16. And you may recall, because we've done quite a few of the base 2, that will end up being 2. So 2 to the fourth does equal 16. Again, not simple to do, not easy to see, but practice does help. And then simplifying. A radical with index n is the simplest form if the radicand has no perfect nth powers as factors. And any denominator has been totally rationalized. So down here, first one, you may think, wow, 135. What can possibly go into that besides 5? Well, I don't know. Let's try 5. Okay, so 5 times what? I think it's going to be 27. So just showing you the steps here. It's going to be 27 times cube root of 5. And cube root of 27, we've had that already. That's going to be, I think that's just 3. So you have 3 times the cube root of 5. There's your answer. Again, sometimes you have to try things. On letter B, this one's tough. Fifth root of 7 or 8. There's no way I can think of anything possible. But you can create a fifth root. Again, through experience. But I know if I multiply this thing by 1, and then 1 can be anything over itself. If I multiply by this fifth root of 4 over the fifth root of 4, that's 1, right? I multiply that. Well, on the denominator, I have 8 times 4, which is 32. So I have the fifth root of 32. Now, some of you are seeing that, I hope. And numerator is 28, fifth root of 28. Well, we know the fifth root of 32. We've had that before. That's just plain old 2. So it'll be 2, and this is the fifth root of 28. And that's now simplified. Remember, you can't have any radicals in your denominator. They're irrational. So by multiplying by 1, I can get that thing out of there. Let's go to 6.2a, practice A. And we'll try a few of these out. Now, the first few at the top are similar to what you had already. We're just kind of going through the operations of exponents. So, like for number 1, you would add those because they're both a half fraction, so they add up easily. For number 2, you multiply numerators, multiply denominators. So that's not so bad. Number 5, you take the denominator exponent since they're the same base of 9, you move the 2/5 up to the numerator and subtract them, and they both have the same denominator as fractions, so they'll subtract nice for you. So that should be okay for you. The next group here is stuff that we just talked about. And some of them are very straightforward, like number 7, square root of 5 times square root of 2. Well, they're both the same root, so you can just multiply those together. That's it. Both the same root, you can multiply and you're done. Something number 9 is a little bit more difficult. The square root of 27 and square root of 3, both of those, I don't see perfect squares, but hopefully you're seeing, I'll get this started for you, you see square root of 9 times square root of 3, because 3 times 9 is 27, and square root of 3 at the bottom. And that looks, hopefully that's a little easier for you to simplify now. Number 11, if you just multiply the two bases, the 5 and the 2,000, multiply those together and see if you get the 4th root of that number. That should be pretty easy as well. And for 12, when you get to 12, please try to write down factors of 10, factors of 21. And you'll be able to cancel out some of the roots. So let me just get you started with this as well. So you have square root of 10 could be square root of 2 times square root of 5. And 21 could be square root of 3 and square root of 7, correct? Well, you know some factors of 15. Put those down in the denominator and see if you can cancel out. That'll help you with that. And then on the B, let's just look at the numbers 1 through 12 for now. Again, you add up those fractions. That's pretty straightforward. These are the same root. Oops, sorry about that. These are the same root. So you can multiply the 2 and the 8. Hopefully you get a nice answer that way. What else looks good here? If looking at this 1/3 is 3rd root of 54 and 64, I think you can find, taking factors of 54, you might find a perfect cube root of that. I think 64 is a perfect cube root, so you should be able to factor the 54 and get some cube roots out of that as well. So I'll assign some of these for you to do, and we'll try to go over these on Friday if you can't get them done. All right, so what I'd like you to try on the A side, pardon me, is 1 through 12. 1 through 12 on A. And then on B, try 1 through 12 there as well. And we can talk about those on Friday. All right, folks, have fun.